Hello everyone, welcome to my channel. Today we're solving balanced binary tree. So we're given the binary tree and we're going to determine if it is height balanced. And height balanced means for each node we're going to check the height of the left and the right subtree, and if they are only different in either 0 or 1, then it is height balanced. The difference is more than 1, then it is not balanced. So for example, this first one, the node 3, on the left it has the height of 1, and on the right it has the height of 2. So only different in 1, so it is balanced. And this next example, this one, for example, the node 1 has the height of 4 on the left and 1 on the right. So 4 minus 1 is 3, so 3 is bigger than 1, so this tree is not balanced. So the way we're going to solve this is using recursion, depth first search. So we're going to search each node. For each node we are going to return the height from the current node plus 1. We also want to return if the subtrees from the node is balanced or not. So for that we're going to use -1, since we either have to use return type integer or boolean. We cannot use both, so we're going to use integer return type, and we're going to use -1 to indicate that the tree or subtree is unbalanced. And other values, it means that it's balanced, and we're going to return the height from the current node plus 1. And the base case for the recursion is 0 for the new node. So in this case, node 9, on the left and the right, they are both new nodes, so they will return 0 and 0. And we're going to compare the left and the right, and we're going to return the max, either the left or right, whichever one is bigger, plus 1. So the node 9 will return 0 plus 1, which is 1. Same thing for the 15, this will return 1, and the 7 will return 1 as well. And for node 20, we're going to compare the left and the right, whichever is bigger. In this case they're both 1, so we're going to add 1 to it. 1 plus 1 is 2. And each time we are going to check if left and the right node, the difference of them is less than or equal to 1. If they are bigger than 1, we can return -1. So for node 3, left is 1, right is 2, the difference is only 1, so this is balanced. So we can return the bigger one plus 1, in this case 2 plus 1, and 3. And lastly, in the original function we can check if the number that we're going to return is -1 or not. If it's -1, then the tree is unbalanced. If it's some number, in this case 3, then the tree is balanced. So let's check when the tree is unbalanced. So when the tree is unbalanced, we're going to return -1. So for example, this node will return 1, and this node will return 1 as well. And we're going to check left and the right. So 1 and 1, the difference is 0, so it is balanced. So we're going to return 1 plus 1, in this case 2. So for the node 2, left is 2, right is 1. The difference is 1, which is balanced. So we're going to return 2 plus 1, the bigger 1 plus 1. So 3. So for the node 1, we have 3 for the left and 1 for the right. The difference is 2, which is bigger than 1, so it is unbalanced. So in this case, instead of returning the bigger 1 plus 1, we're going to return -1. And in the original function we're going to check if it's -1. If it's -1, which we use as a false statement instead of false boolean expression, So we can say that the tree is unbalanced by checking if it's -1. So that's basically it. Let's write up the solution. So we're gonna use a different function, but we can maybe call the function first. So we're gonna use the root, and we're gonna use another argument, which is a height, and it starts from 0. So we are going to return an integer. We said that we will check if it is a -1. So if it's not -1, it's going to return. We can return true, and if it is -1, we can return false because we use a -1 as a false expression. Alright, so let's write up the recursive method. So we can say public, and we're gonna return an integer. So public int dfs. The argument is tree node, and also the level, which starts from 0. We're gonna have a base case for the new node, so we're gonna check if the node is null. So if node is equal to null, we are going to return 0. And then first we're gonna traverse down the left, so we can have a left pointer integer of type integer, and we can call the function, and the argument would be node.left, and we're gonna add 1 level to it because we are going to traverse down the left, and we're gonna increase the level. And after the function returns, we can check if the left is -1, because it could return -1 if the tree is unbalanced. So in that case, we're just gonna return -1. We're gonna do the same thing for the right subtree. So we can copy and paste this. We're gonna have a right integer variable, and we're gonna traverse down the right this time. The level we increase by 1. We can check if the right is -1, which means the tree is unbalanced, and then we can just return -1. So after that, if the left or right isn't -1, then we are going to check if the left and the right variable, we're going to check the difference and see if it is less than or equal to 1. And if it's bigger than 1, then it's unbalanced, so then we can return -1 again. So we can check if the absolute value of the difference between left and the right variable. So if the absolute value is greater than 1, if the difference is greater than 1, then it's unbalanced. We're going to return -1. And lastly, we are going to return whichever is bigger, right? So in this case, 2 is bigger, and we said that we're going to return the bigger one plus 1. So we are going to return math.max to get the bigger one of the two. So left and the right plus 1. So that is basically it. Let's check if this works. Alright, so this was balanced binary tree. Thank you for watching.